Hello viewers, welcome back to my channel. I hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problems such as breadth first search, depth first search, dynamic programming, sorting, searching, binary search, and so on. Please check them out. I have uploaded the code for this particular problem to GitHub repository. You can get the link from the description section of this video. Let's jump into today's problem. Find all anagrams in a string. Given a string S and a non-empty string P, find all the start indices of P's anagrams in S. String consists of lowercase English letters only, and the length of both strings S and P will not be larger than 20,100. The order of output doesn't matter. So basically we are given with two strings S and P, and we need to find all the P's anagrams in S. Okay, so let's see and understand what is an anagram first. Okay, so let's take an example. P is equal to ABC. Okay, so what are the anagrams of ABC? Anagrams. So ABC itself is anagram, ACB is anagram, right, and BAC is anagram, BCA is anagram, CAB, CBA. So these are all like anagrams of P. P's anagrams we'll say. Okay, so the string is P, which is ABC, right, and P's anagrams are all these things: ABC, ACB, BAC, BCA, CAB, CBA, and so on, right? So these are all like anagrams of P. And in the string S, right, string S, let's say take the same example, whatever it is given, right? So this is S, right? So in this string we need to find the indices where the anagram of P appears, right? So the anagram of P, so we need to check for all these things basically, right? So let's say for ABC, these are the anagrams. So we need to check whether ABC is there, right? No. ACB, no. BAC, no. I'm just checking by looking at it, right? So BAC, right? So that is there. So this is at which index BAC is there? So it is 0, 1, 2, 3, 4, 5, 6. So let's put answer list 6. Okay, we found BAC. In this particular string there is only one instance, right? So let's say if BAC is there, you need to write 6, 7, 8, 9, 10 also, right? But since it is not there, we just ignore. Okay, so there can be multiple instances, but in here we just found one instance BAC and we are done with it. And then CAB, do we have anything? No. CBA, yes, that is what is the first instance, that is 0, right? So this will be our answer, right? So that's how we have to understand the problem. Basically the anagrams of string P are multifold. It's not just the string whatever you are given with, right? So we have to check for all the anagrams of P, not just what is the real occurrence of P. So if it is a real occurrence of P, then it's probably straightforward, but anagrams, there are so many anagrams for a given string. It depends on the string length, right? So do we actually need to calculate all these anagrams is the question, right? So by definition the anagrams will have two properties, right? So anagram will have two properties. One is same length, right? So ABC and ACB same length, that is first thing. Second thing is each character occurrence is same. Each character occurred same number of times, right? So these two properties will hold for anagram. You can take ABC and CAB. So A occurred once, B occurred once, C occurred once, similar to P, right? So these two properties should satisfy for an anagram, right? So we are going to utilize this piece of information to solve this problem, right? So we are not going to generate all the anagrams, but we just use these two properties to solve this problem. So one thing is, we could start with the first character in the string S and see if that matches with any character in the P. So what we do is, we put P in a hash table basically and check if the character that we are currently at in S is existing in the hash table. If so, we consider, okay, there might be a candidate here. So C, there is a candidate. B, so now it's a strong candidate. And A, so C, B, A, it became same as ABC. Now we will say, okay, this is a anagram position. We will put 0 into the answer array, right? So that's how we can proceed. So, but in that particular case, what happens is, you need to do for every string, right? For every character position, you need to verify. So that is what we are going to do in our logic. So first, what we are going to do is, we build a map, okay? Build a map for P. So what is that? It will be the map will have character and its occurrence, okay? Character and its occurrence. So that is a map for P. And next, what we are going to do is, once we have the map built for P, we will go through the string S and try to build a map for S also, right? So we try to build a map for S also. Whenever the map for S and map for P are of same length, then we will see if they have same occurrence also. That is what we said, right? It should have same length and each character occurred same number of times. So we keep on building the map for S, and if it is same length, we check for each character occurrences, the number of times each character occurred. If they are also same, right, then we will say, okay, we have encountered an anagram, and we say, okay, we correspondingly store the index in the answer array, right? So while building the map for S, we only consider characters which are equal to the piece length. So in this particular case, we are piece length is 3, right? So the length is 3, right? So as long as the map's length is 3 while we are building S map, we will check whether that particular maps are having same character occurrences or not. So that is the logic. So we will keep on building the map for S, and whenever it reaches to the length of the P, we check whether the characters are same and its occurrences are also same. So whenever we match both conditions, the same length condition and each character occurred same number of times condition, if these two conditions matches, then we will say, okay, there is an anagram of P that has occurred, or maybe P itself has occurred, we don't know that, right? P itself has occurred or P's anagram has occurred. So we will say the corresponding length we will add into the answer array, okay? So let's go and look at an example, the same example that we are going to take, and try to follow through it. So S is equal to whatever the first example 1 and P is equal to ABC. So now I have built a map, A one time, B one time, C one time. So this map is for P. So this we are saying P's map, okay? Now we are going to build the S map, right? S map. We are at an index I is equal to 0, and the map is I is equal to 0 means C occurred once. So maps are not equal. So we don't do anything because it is not yet equal to the length of the piece and not yet equal to the length of p, right? Equal to length of p, right? So similarly it's here, right? When I is equal to 1, that is b, so we put c1 b1, maps are not equal and not yet equal to the length of the p also, right? And going further, I is equal to 2, so now c1 b1 a1, right? So maps are equal and the length is also equal to p, and moreover each character occurrence also same number of times, right? So C occurred once, B occurred once, A occurred once. So C occurred once, B occurred once, A occurred once in P's map. So they are equal. So put I minus P dot length plus 1 into the answer list. So I am putting an answer. So the I is what? 2. What is P dot length? 3 plus 1. 2 minus 3 minus 1 plus 1 is 0. So put 0 into answer list. That's what we are doing. And since we have achieved the length of p, right, now we are going to move on. We are going to update the map. So we are going to remove the 0th character. What is the 0th character? C. So C's corresponding character we will remove. C is 1, right? We removed C. Our map will become B1 A1 now. Okay. And next we move on. I is equal to 3. So at third it's E, right? So B1, A1, E1. Maps are equal in length, right? But each character occurrence is not same. That's why I'm saying maps are not equal. So update the map. So our answer is still 0 only, but update the map. Now what we are going to remove? I minus P dot length 1. So we are going to knock off the 1. What is 1? B. So we knock B off, right? So once we knock B off from this, what will remain? A1, E1, right? So now look at the fourth character. What is fourth character? 0, 1, 2, 3, 4, B. So we add B into that one. So A1, E1, B1. So length is equal, map's length is equal, but the content of the map is not equal. That means the occurrences are not equal. So our answer is still 0 only, and update the map. So now we are going to knock off the ID2, right? So I is equal to 2 character, that is A. So we knock the A off. What is remaining? E1, B1. So on we will continue until let's come to the step 8, right? I is equal to 8. So at I is equal to 8, previously the map has B1 and A1, and when I is equal to 8 at this location, C occurred. So C1, B1, A1. So now maps are equal. Not just they are equal, but the character occurrence is also same. So now update the map and add I minus P dot length plus 1. What is I? 8, right? 8 minus 3, right? 8 minus 3 is 5, plus 1 is 6. So add 6 to answer. So add 6 to answer. Now our answer became 0 and 6. And remove the index 6th element, right? What is index 6th element? B, right? So knock B off. So from here we knock B off, we will remain with C1, A1, right? So on. So similarly for 9th step also we are going to do same. A, C, D. Here maps are same length, but they are not equal. Update the map. What we are going to knock off? 7th character. What is that 7th character? A. We are going to knock the A off. So finally we are ending the length of the string S. What are we left with? Answer 0 and 6. So 0, at position 0 the anagram starts, at position 6 the anagram starts. So that is what the answer that we want for example 1. If you look back the output, right, 0 and 6, right? So now we are ending with 0 and 6. So essentially this is what the flow that we are going to follow in order to solve this particular problem. Let's go ahead and look at the code for this. Okay, it's a simple code. So basically we are checking these two things, right? For these two things we have to check whether two maps, the S map and P map, satisfy these conditions. two conditions, same length and each character occurred same number of times. So let's go ahead and look at this function first, which is doing this validation, right? So check if maps are equal. So we are passed with map A and map B, right? So first check their lengths. If the count of them are not equal, then and there you return false. But if counts are equal, then you have to check whether they occurred same number of times or not, right? So it should contain the key and it should contain the same number of occurrences, right? If so, we are good. Otherwise, we return false. So once it goes through all the characters and their occurrences, if they are equal, finally it is going to return true, right? So this is what is making sure our map S and map P are having equal length and their corresponding character count is also same. That is what we will be using this function, right? So now go back to our main function, right? So we are passed with S and P, find anagrams. So I am creating the answer list to return the answer and create a map for P. So this for loop is going to create the map for P, right? So it will have this kind of structure, basically the character and its count, right? So P's map is created now. So now I am creating another map called S map, just like we did S map here, right? I'm going to create. So what we are going now, we are going through the string S, right? So if S map doesn't contain it, right, we add that and increment it, right? So basically we are building the S map here. If I is greater than or equal to P dot length minus 1. So what we are doing essentially is we are waiting till the map builds up, just like here. So when I is equal to 0, the map's length are not equal. We don't actually do anything. At I is equal to 1, maps length are not equal, right? When I is equal to 2, maps lengths are equal, right? So that's what this condition is used for, right? I is greater than or equal to P dot length minus 1. So now check if maps are equal. So we pass the map and S map. So this map is for P, right? String P, and S map is for the string S. So check. If at all check map returns true, that means the length should be same and the character occurrences also should be same. In that case, we will add I minus P dot length plus 1. So that's what we were adding previously, right? So I minus P dot length plus 1 to the answer list. So we added answer 0, the 0th index, right? That's what we added. And now once we adding, right, we have to update the map. So now we are proceeding further, like to the right side of it, right? So we knock of the corresponding element from S map. So if that corresponding element count becomes 0, right, we remove it from the S map. Basically we are knocking that particular element or the character from S map. So we continue this until the length of the S, right? So like we saw it in example, right? We continue that until S dot length. So finally whatever we are left with answer, we are going to return, right? So that's how we proceed and solve the find all anagrams in the string. So let's go ahead and look at the time complexity for this. And one more thing that we haven't really gave attention to is all the characters in S and P are lowercase English characters. So lowercase English means lowercase, right? Lowercase English, right? So how many characters will be there? 26, right? A to Z. So there are only 26 lowercase English characters, right? So that point we are going to use while doing the time and space complexity. So time and space, right? So what is the time required? So this for loop is going through the length of P, right? All the characters in P. So I will call the length of P as P only, length of S as S only for now, okay? What is length of P? Order of P, right? Plus, so this for loop. And the second for loop is going through what? length of s, right? So that will be order of s. At every character almost after the p dot length, right, we are checking if the maps are equal. But what the map has is, map has a character and corresponding counts. So how much time our check if maps are equal is going to take is the question. So that depends on the size of the map. So size of the map will be how much? Since we are dealing with only 26 characters of English, that is lowercase English, right? So check if maps will be executed, this for loop will be executed maximum of 26 times, right? So this will be executing 26 times. So we need to multiply this 26 with s dot length, right? Because check if maps are equal function is going to run through 26 different characters. So for that case, what we will say is order of 26 into s, right? So that will be the total time complexity. So if we add that, right, order of p plus 26 s, right? So normally we will remove these kind of constants from big O notation. In that case, what we will end up with is order of p plus s. Okay. So I would like to remind you one more time, the p that I am referring is length of p, s I am referring as length of s, p length of string p, okay, and s length of string s, okay. So that's how it is going to be, the time complexity. And let's look at the space complexity, what space we are essentially using. So space complexity we are using for map. How much space that we are using? It depends on the unique characters in string p. But since we are dealing with only the English lowercase characters, what would be the space required for map? It will be order of 26, right? That's it, order of 26, because there are only 26 characters. So there is 26 characters and there are corresponding integers, right, the counts, plus how much we are using for s map. Similar, right? Similar, because even s also has the lowercase English characters. So that will be order of 26 again. So if we add them up, it will be order of 52. So sometimes it will be represented as constant. Okay, we will say this is a constant space, right? So this algorithm that we went through is a constant space and order of p plus s, where s and p are lengths of string s and string p. So that is how we are able to solve this particular problem, finding all anagrams in a string. So if you have any further questions, please post them in the comment section below this video. I have posted the code to the GitHub repository. You can find 2 links in the description below this video. The links are for 2 languages, one is for C# and one is for Java. If you haven't subscribed to my channel yet, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified with all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.